So I will talk about data anatomy and aesthetics in my talk for these 20 minutes. My name is Christian Schneider. I live and work in Bern and Vienna. What do I do? I'm really into looking how data visualization can make complex data more accessible with a focus on complex data. I like to search for patterns in data and reveal those patterns. And I'm particularly looking for finding the hidden beauty in data, because I'm convinced that there is beauty inherent in data. I have a computer science background. I studied computer science. I worked in architecture research for 5 years at the ETH Zurich, before I changed to the statistics office of Zurich, where I worked for also about 5 years. And since some years, I'm working independently. Here you have my contact details, website, email. So what will I talk about today? I will just give an insight how I usually work, how I deal with data. I will just kind of show my approach when I start to work with data sets and visualize them. There's a bit of philosophy coming in here, and I try to kind of pinpoint and ground what I say in project examples. These examples are mostly projects I was working on, but some of them which I show are projects from other people, which just kind of nicely illustrate what I mean. So I'm working kind of in the realm of generative design and data visualization. If the black circle would be generative design, I see the orange circle as data visualization. So I actually see data visualization as a part of generative design. Why that? Because both for me is painting by numbers. Especially for me, as I'm coming from a computer science background and I'm programming a lot, it's just both is painting by numbers. So you always have numbers which you somehow transform into geometry. There are systems like we've seen before in the two previous presentations. The numbers, they come from data, numerical data or other data, and these data, they stem from the real world, or you actually generate them through a simulation or through a generative design system or something like that. So we have some similarities here. And so my goal is to kind of take this circle of data visualization, how it is today or how it was 10 years ago maybe, and bring it more into the realm of generative design with the possibilities of generative design. Yeah. So I always work with code. I don't have any Adobe program installed on my computer. That's the only thing I do. I work with code for data manipulation. I work with code for visualization. I work with code all the time. And I think the fact that I'm working with code influences a lot what comes out of the work I'm doing. So when we speak of data, we often imagine something like this. We have like it's something in a tabular shape, a lot of numbers, somewhat abstract. Some people are afraid and walk away. Some people think it's very, very boring, but I think it's actually very interesting. If you look at data as a mountain, we can ski kind of down this mountain in different ways. We can ski down this mountain in a very efficient and strategic and accurate way with really professional tools, for example. We are well trained, we have techniques, and we have a goal with a specific outcome. That is one way we can deal with data. The other way is kind of a free ride approach, where we just start to play with data and look what comes from the data and where it brings us. So when I work with the data sets, I always have the assumption that there must be some kind of hidden aesthetic in this data. Why is that? Because data is always kind of a mirror of the real world. And when you go to the real world, if you go to nature, if you have geographical data, if you have sociological data which are based on people and their interactions, if you have maybe urban data or traffic data or weather data, it's always based on our real world, the real universe. And oftentimes what you find is kind of an inherent beauty in that. So, if you take a plant, it's usually kind of beautiful in the form, but it is a masterpiece of engineering in a way from nature. At the same time, it is highly optimized. So that's kind of the assumption, that because data is a mirror of the real world, there must be kind of some aesthetics hidden in that. And I would like to illustrate that on this example here. It's an older work I've been doing some years ago. I call it Silk, and it has a certain aesthetic to it. It's computer generated, but how was this generated actually? So let's look at this, how it was generated. What we have here is a simulation of a rope kind of growing in zero gravity, and it kind of just moves in space here. But it's a physical simulation. So we have physics. And so if my assumption is right, if we use physics here, there must be some kind of hidden aesthetics in that. But this alone, I don't really like that much from an aesthetic point of view. And what if we just don't draw this rope directly, but we draw the path of the single elements of the rope? Then we get something like this. And we see kind of the sum of paths of each element of the rope, kind of creating the shape in the end. So you get an idea. You get an idea from the darkness or the lightness of the colors. You get an idea what was happening in terms of speed, where the rope was. Where was it more? Where was it less? Where did it move faster? Where did it move slower? I'm always interested in raw data. So if I work with a client and he gives me data sets, oftentimes it's kind of aggregated data in a certain way. Then I usually ask, well, do we have the raw data of this data? Because in the raw data, there as well, my assumption is that it's kind of closer to life if you take the raw data. And when it's kind of closer to life, to the reality, maybe it has some different stories to tell you, which you are not looking out for at the moment, but which are really interesting. So I think if you can work with raw data, it's kind of like with food. If you have like fresh kind of food, you can also make fresh, nice meals. As opposed to processed data, where I think if you process data too much, you lose something. On the one hand, you definitely you lose information always if you process data too much, and you kind of, with the information that you lose, you might also lose some kind of interesting aspects of the data which you weren't even looking for, but which could be revealed somehow when you work with the data. So I want to illustrate kind of the beauty of raw data with this example, the racial dot map. It's quite an old work, it's not from me, but it illustrates nicely kind of an approach I have. So what we see here is we have a map of dots. Every dot represents a person. The color of the dot represents the ethnicity of the person, and the location of the dot represents the address where the person lives. So we have a really, really simple visualization. We just have dots here. The data set is also quite simple. We have a person living at a certain location and having a certain ethnicity. It's quite a simple data set. But when we visualize the raw data here, suddenly we get information which is inherent in the data, but not explicitly there. For example, we clearly see, this, you see the geographic boundaries of the United States, for example. You see where cities are. You see where rural areas are. You see where the white people live, so the blue dots. You see where the black people live, the green dots. But you even see where mountains are and where flatlands are, just from drawing dots. And I think that's very, very interesting. And such effects, they might be there in any kind of data set, even in more abstract data sets. And that you suddenly, if you visualize the raw data, that you suddenly something appears which you weren't looking for, or which is not explicitly in a row or a column or something like that in the data. And then, of course, the raw data invites you to kind of to look around and to explore. And somebody did that. Somebody wrote the blog, and this person then discovered that in areas where there are many rural areas where there are many white people living, which are not densely populated, you always have kind of an area which is very densely populated, where there are mainly black people living. And you see this pattern again and again all over the United States. And this person was asking herself, well, why is that? And that's my question to the audience. Why is that? What's happening here? Why do we have a densely populated area with a lot of black people in an area which is not densely populated, mostly of white people? I mean, maybe you can write it into the chat, and maybe Darian can tell some assumptions.
Okay, I'm nothing there so far.
Okay.
I'll give it 20 seconds, otherwise you answered.
Yeah, otherwise they'll... So what could that be?
Okay. There's one. I tell one. There's one. One came.
There's one.
Prisons.
Exactly. That's it. And then you can ask yourself, okay, why is it that so many black people are in prisons? And then you have this sociological question and so on. We don't go into the details of that, but these are the kind of patterns that suddenly arise when you work with raw data. This work here is a work I've been doing at the University Clinic of Regensburg in Germany, in Bavaria. I worked with a group of scientists there, psychiatrists and psychologists. They were doing research on tinnitus, this kind of annoying beeping noise that you sometimes hear, which is produced by the brain. And they had a data set of 5,000 patients, tinnitus patients, and they had information of these patients at a given point in time. How strong was their tinnitus? How loud was it? Which kind of tone frequency did it have? How was their mood when they had this tone frequency tinnitus, and so on. So it was a very high-dimensional data set of 5,000 patients approximately, and they just told me, well, just do whatever you want with this data, and we'll look at it at the end of the week. So we decided to do like this kind of science fiction-y multi-dimensional visualization with these cubes, three-dimensional cubes, where you always had three axes, X, Y, and Z axis, where we mapped different kind of variables of the data set. So you get kind of these different shapes of the data, depending on how you look at the data. And here in the left side, with kind of a two-dimensional view of the data, where you could select certain data points, and what you select is also visible in the other visualizations. And so then at the end of the week, I showed this to the scientists, and these scientists, they really knew their data set very well. They wrote papers based on the data set. They were really adept. They had adept statistical skills. So they really knew the data sets really well. But when they looked at the visualizations, they were like, oh, okay, what's this patterns? Why do we have these dots here? And they started to look at their data set from a different angle. And sometimes the patterns that they would see, which they would observe, they would be very obvious patterns because the data, or obvious correlations that you would see, but sometimes it was kind of a surprise to them. And then they decided to kind of look at this group of patients, for example, more precisely. And then they were like, because they're scientists, they were like, oh, okay, let's write a paper about this. Something like that. So this is an example. If you kind of just play with the raw data and it's just try to visualize it in different ways, I think already this can kind of inspire people to do things or to explore the data set further. Then and next project I would like to talk about is this here. It's called Urban Data Patterns. I made a series of visualizations together with the graphic design and communication bureau in Bern called Hahn and Zimmermann. We made this project, Urban Data Patterns, and made several visualizations based on different urban data sets. And this is one of them. What you see here are the trees in the city of Bern. One tree is one line. The length of the tree is the age of the tree. The color of the tree is the type of tree. So is it kind of a pine tree, or is it a tree with leaves or something like that? Is it the fruit tree? And then the location of the line is the geographic location in the city. So this could be a street or a park or a kind of a square or something like that in the city, like a geographic location. And so what you see, you get these different shapes, which are kind of characteristic for a certain geographical location. So what you get, for example, here you get like many old trees and very few young trees, or here you get just a few old trees and many young trees. So this gives kind of a characteristic shape of each geographic location. There's a website also with that, urban-patterns.ch. Then what I would like to show here is that, well, sometimes you don't really need to. Well, what I was experimenting here is kind of trying to not visualize the data, which is in the data set. Well, the data set here was the building footprints of Zurich. And I was thinking of how can I kind of show this data without explicitly drawing the data in the data set, because usually we take the data and we're transforming in some visual variables like we've seen before in the book presentation. But what if we're not allowed to actually transform the data into visual variables? So what I did instead is kind of simulate people in the city, how they walk around. So it was just an agent system, and they weren't allowed to walk into buildings. So when they would kind of walk into a building, they would just turn around and walk away, and you would just trace their path. And that's what you then get. You get an idea of the city of Zurich, you get an idea of the streets, for example. But I didn't visualize the data set itself, which is underlying, which is the building footprints, and that's the result. here a visualization, animation of that process. And here a close-up. And that's it. Thank you.